Okay.
Okay, the reference angle, there's a lot of feedback. Is there, let me know if you could turn your volume down. It's better now. Okay, so reference angles, trying to decide what the best way to explain this to you. I guess I can share my screen. Well, okay, yeah, I guess I do need to share your screen, my screen. All right, so let me grab this here. All right, so your angle is 8 pi over 3 that you were given, and you draw your crosshairs or your axes like this. And if you were to go all the way around once, that's 2 pi. All the way around is 2 pi. Okay, so 2 pi in terms of like this denominator is really 6. I'm sorry. Yeah, it's a 6 pi over 3. So this is 6 pi over 3 when you go all the way around.
And now, then how did we get to pi over 1?
It just every number can be written as a number over 1. So let me start back. Let me start back fresh here. Okay, so this is 0, and if you go to this position right here, that's 90 degrees. But if you go all the way here, that's pi. So all the way here is pi, and because we have a denominator 3, we want to put a 3 pi there over 3. This reduces to just 1 pi, which is this position here. Okay. And this up here, it's halfway between 0 and 3 pi over 3, so it's actually 1.5 pi over 3. And then if you keep going, it's another 1.5 pi over 3, so it's 4.5 pi over 3 here. And then if you go all the way to this position here, it's now 6 pi over 3 or 2 pi. Okay, but we still haven't hit the number here. So we got to figure out, well, where is 8 pi over 3? Okay, and you do that by keeping going on this. So let me actually try something different here, because I don't think this is very helpful. Remember we talked about adding and subtracting 2 pi or 360 degrees? Okay, let's do that.
Yeah.
Now, this is 8 pi over 3 minus 6 pi over 3, which is 2 pi over 3. And I'm going to send you a link to a unit circle, unless you already have one. This is a reference sheet that you're going to want to have for the rest of this class. There it is. So let me send that to you in the chat here. And you're going to want to look on page 3 of this at some point. So if you look at page 3, and I'm going to snip it in here, it'll tell you where 2 pi over 3 is. So 2 pi over 3 is right there. So the reference angle is always the angle that's made with the x-axis. And that's what I was trying to get to, is to get you to see where it was on this unit circle here. So the angle that's made with the x-axis, it's pi minus 2 pi over 3, or if maybe visually can see this, it's the same as this angle right here, which is pi over 3. So all of that to get this number right here. So rather than you sharing your screen, maybe just tell me the reference angle for the next one, and we'll see how much clearer this can be. What is the angle that they give you in question 2?
Okay. So is this like a 0 or?
This is the Greek symbol theta. It's a Greek letter.
Is it
theta?
Okay. So how do I say it, I guess?
Theta, or you can say the angle. Angle equals angle is.
Okay. Well, it equals -5 pi over 6.
Okay. So yeah, kind of another weird one. Man, there's like there's a lot that goes into this to be able to just answer one question, and that's why this is such a complicated question. I mean, I can just give you the answer, but that doesn't help your learning.
Yeah.
But because you're going to eventually have to do this on your own now, like, and this is pretty overwhelming to just look at this. So if this were positive 5 pi over 6, do you see that 5 pi over 6 is right there on this angle right here?
Yeah.
Okay, but negative means we're going the other direction. We talked about this clockwise, counterclockwise stuff. So negative 5 pi over 6 is actually here. So this is negative 5 pi over 6. Now the reference angle is always the angle that's made with the x-axis. So it's this angle right here. Okay, and so you have to be able to come up with this angle right here. In this case, it's pi over 6. And we'll start talking about how to do that, but it's more complicated than just like adding or subtracting.
Yeah.
Whenever you're ready, go ahead and give me
Okay,
that next.
Next one is just -100 degrees.
Negative 100 degrees. Okay, fantastic. So you'll notice in that unit circle that I've snipped in here a couple of times here, it's got both degrees and radians. So negatives are always weird. Let's go where 100 degrees is. So 100 degrees is gonna be like kind of right here, roughly. This is 100 degrees. It's got to be a little more than 90. So negative puts it in the other direction. Like we got to go this way, maybe a little more like that, right? This is a negative 100 degrees.
Right.
Okay. Now you have to figure out the angle, this angle right here, the reference angle, and it's always positive. Okay, so like there's a couple of ways to think about this, but like I don't know, maybe visually, since this is 180 and this is minus 100, can you tell me what angle measure this is? Maybe.
-200 or -90.
Okay, so they're always, it's always positive. Okay, so it's got to be a positive.
200?
Like what do you need to add to 100 to get to 180?
80.
Yes. So the reference angle here is 80 degrees.
Okay. Next one is 150 degrees.
So theta equals 150 degrees. This one will be much more straightforward. Where is 150 degrees on this picture?
Yeah, right there.
Right there, yeah. It's in the second quadrant. So you have to figure out this angle right here. This angle right here. So if you keep going, it's 180. So how do you get the reference angle? What is how much more do you have to add to 150 to get to 180?
30.
30. So that's your reference angle.
Okay, well these are actually pretty easy.
There again, I'm showing, but if there were multiple choice, you might see 30 minus 30, you might see 60 minus 60. You could see a lot of numbers that appear to be correct. It's always the angle that's made with the x-axis.
Right.
Okay. What's the next one here?
-370 degrees.
Okay. So I'll draw that unit. I'm copying it in each time. So if you go negative 360, okay, you're starting here and you're going all the way around, but you're going that direction. Do you see that? You're going all the way around clockwise, but you also have to go another 10 because 370 is obviously 10 more than 60. So you're going just a little more. You're going like right there. Okay. So that's where you're at. You're on this thing right here. How much to get back to 360?
10.
10. And again, it's always positive. Reference angles are always positive.
Right.
Now there are formulas for each quadrant. But I find that drawing it is better than writing the formula.
Yeah.
You also have to account for degree and radian and whether it's positive or negative. So there's actually a lot of formulas. So it's not that trivial. So what's next?
That's a lot. Okay, next one is 15 pi over 4.
Like this? Yeah, now the first step actually is to reduce to something between what's called minus 2 pi and 2 pi, or minus 360 to 360, basically finding the coterminal angle. Okay, so you do that because by subtracting 2 pi or adding 2 pi. But you have to make a common denominator. So it's 15 pi over 4 minus 8 pi over 4, which is 7 pi over 4. So once you have that, 7 pi over 4, you snip in your unit circle and you're like, where's 7 pi over 4? There it is. So to get there, you're going counterclockwise there to get to that point. And then the reference angle is the angle that's made with the x-axis. That's right there.
Right.
So how much do you add to 7 pi over 4 to get to 2 pi? If you're more comfortable, you can do it in degrees, but you have to convert it back to radians. Like maybe you can see that it's 45 degrees. So it's this pi over 4.
Okay. And then can you go up so I can write down the steps?
Yeah, the problem though is that it's really there's more than this. Like I'm not really giving you the full, everything.
Right.
It's really complicated, and it depends on whether it's in degree or radian, which quadrant you're in, whether you went positive or negative.
Right. Okay. 4. All right. Next one is I don't know how to say it. It's CSC.
Why don't you share your screen again, if you don't mind?
Okay.
Thank you.
There you go.
Yeah. Okay. The thing is, though, here is you actually can use a calculator potentially. Oh, this one isn't multiple choice. I'm sorry. All right. Yeah. Well, I'll have to do this. So you'll just have to give these to me, but I'll share my screen here and show you to work through it. Okay, so the first thing is that you really only want to work with positive angles if you can. So we need to add 360 to this. So that's the cosecant of minus 60, but it's still not positive. So you add 360 again. And that's cosecant of 300. You follow that?
Yeah.
Okay. Now on this unit circle that I keep showing over and over and over again, and I really hope you can use this, like you really should push hard for not having to memorize this. Where is 300 on this unit circle?
In the fourth quadrant.
Fourth quadrant, yep. Yeah, and it always goes counterclockwise. So you notice there's all these XY pairs. Do you see that all over the place? So the X is cosine and the Y is sine. And cosecant is really 1 over the sine of 300. So when you look at this ordered pair right here, X is cosine, Y is the sine. What is the Y value?
Yeah.
I'm circling it. I'm trying to get you to focusing on that. The y value.
Sorry. It's 3. I don't know how to say that. I forgot how to say it. Rad 3/2.
Yes. So the sign of 300 is this. It's this minus square root of 3/2. And see how cosecant is 1 over sine, so it's 1 over this. So see, like, and I'm not trying to like, this isn't to like scare you or like make this weird or anything like that, but it like there's one step here, there's a second step here, there's a third step here, and there's now a fourth step here. And it's a lot to do. It's a lot to do. I'm like I want you to see like there's really quite a bit that goes into every problem here. So this is the correct answer. This is unsimplified, but this is the correct answer.
Okay.
And I don't think you need to simplify it, but just, you know, let me know if you have any issues entering that. We'll leave it there for this problem, hopefully. Hopefully the next ones are easier.
Yeah, I hope so too. This is like really hard. It's kind of hard to comprehend. But no. I think it wants me to. Oh wait.
Go into your screen. You know, it's very important that be entered. Well, actually, so another easy thing to do is to just flip it. This is also not reduced, but
This is on that.
yeah. So it doesn't seem to like that. Okay, so go ahead and do this for me. Type how many attempts are we at on this? Oh, I was gonna have you.
We're at 2, so
Okay.
the next one will be the last one.
All right, go ahead and get to where you can edit that, please. And I'll tell you what to put in. Hopefully this will.
Okay.
All right, yeah, so this is right. Okay, so type in -2 square root or rad 3. Yep, that's square root symbol there, top right. 3. And then move your cursor to the right or select all that. It's going to be all divided by.
Oh.
Maybe you can undo. I don't know if that's an option. Nope. The square root of 3's got to be nope. Okay. You that we got to do it differently. So the square root of 3 has to go on the top.
Yeah. Okay.
No, it's -2 square root 3 in the numerator. Nope. Okay, put a 2 there in the top, 2 in the top.
2 up here.
No, in front of the root.
Okay.
And then in the bottom, put a 3. And this is the
Why isn't that going?
Yeah, not sure. Sometimes you got to use the arrow to the right on your keyboard to get it to go down to where you want.
Okay.
Good.
What was the bottom one?
3. Okay, let's try that. Although, is that thing out in front? Okay. So, okay, let's go to the next one.
Mm-hmm.
All right, so this is, I'll share my screen here. This is tangent of -3 pi over 4. Let me share my screen. Okay, so this problem, again, we want the angles to be positive, just as like a niceness thing. Like you have to add or subtract 2 pi. In this case, we're going to add 2 pi. When you add 2 pi with a denominator 4, it's really like adding, this means you're adding 8 pi over 4. Okay, so really adding 8 pi over 4 to this, so that's tangent of 5 pi over 4. That's step 1. Now we go to the unit circle, and you have to find 5 pi over 4. And you'll see it's right there. Tangent is really sine over cosine. So it's really sine pi over 5 pi over 4 over cosine 5 pi over 4. Sine is the x value. The x value here is minus square root of 2 over 2. I'm sorry, sine is the y value, but it's actually the same there. Cosine is the x value there, which is minus square root of 2 over 2. So these are the same, so it just equals 1. There's nothing more to do there with that.
Okay. Oh my God. I'll just share my screen with this one.
Okay. Yeah, if you think you can just verbally tell me, that's okay too.
I don't know how to say this one.
So you can just say the 3 letters. You can say COT. It's cotangent of minus 8 pi over 3.
Okay.
So again, let's because another thing that will work for some, but not all. Do you see that Desmos scientific calculator there, that tab there?
Yeah.
So I'm not guaranteeing it's going to work for all, but some of them it will work for. So you may want to try that as like your shortcut for this. I'm going to share.
Like if I put it in.
Right, but remember, it doesn't know cotangent, so you have to know how to change cotangent, and I'll show you that here. But again, there's just it's not all. There's fewer and fewer shortcuts here to getting this. So
right. Okay.
In terms of your Desmos, you would want to do 1 over the tangent of minus 8 pi over 3, and you're welcome to try that. I don't think it's going to give you a nice number, but you can always try that.
So I put 1 over what?
The tangent of minus 8 pi over 3.
So I put tangent over.
It's got to look exactly the way it's printed here. And then you have to make sure your mode is in radians. But again, that it probably won't work most of the time. It would have worked on the last one because it was a nice number. The answer was, 1.
Is that over 1?
So I'm going to work through this by hand because this is the more generic approach that will work for most problems. So we want to add 2 pi to this, but we want to make it with the same denominator. So that's 6 pi over 3. So when you add it to this, you get cotangent minus 2 pi over 3. It's still negative, so you add 6 pi over 3 again, and you get cotangent of 4 pi over 3. And then we grab the unit circle. You'll notice we're going to do this. It's almost better to even have one printed out. Cotangent is really 1 over the tangent, 4 pi over 3. That's the reciprocal property. So when you go to your unit circle here, you find 4 pi over 3. There it is. Okay. And then tangent, if you recall, tangent is sine over cosine. Sine 4 pi over 3 over cosine 4 pi over 3. And whenever you have a fraction like this, whenever you have 1 over a over b, you flip the fraction, so it becomes b over a. So in this case, it becomes cosine 4 pi over 3 over sine 4 pi over 3. So now we go back to our unit circle and we look at these 2 points. The x value is the cosine, the y value is the sine. So it's minus 1/2 over minus square root of 3 over 2. So whenever you have the same fractions and same signs here, the fractions cancel. So it becomes 1 over the square root of 3, but we need to rationalize. So to rationalize, you multiply by the square root of 3, top and bottom, and that gives you the square root of 3 over 3 as your final answer.
Ooh, almost exit out. Okay. Okay.
Oh, empty.
So the next one is cosecant 7 pi over 4.
Okay, very good. Cosecant is really 1 over the sine of 7
Oh wait,
pi.
I'm so sorry. I said the wrong one. It was just COS.
Okay, so that's cosine. Cosine is
Cosine, yeah.
COS. Okay, so the nice thing about this problem is that it's already on the unit circle. Okay,
Mhm.
and what I mean by that is like the angle, it's already on here. Like you don't have to add or subtract 2 pi. Okay, now cosine is the x value. The x value of this ordered pair is square root of 2 over 2. So this one doesn't require you to do anything other than look it up on the unit circle.
Okay.
So there is kind of a shortcut here. If you want to give me a moment here to pull something up.
Yeah.
So in our last lesson, I think I started writing this down. Just want to go find it real quick. There is a way to use your calculator, but you just have to know what to look for when you do it in the calculator. So let me show you this. Let me go find it. Learning, students, lessons, notes. We met last week. Okay, so let me see if I can help you by snipping this in. So what is the next? Okay, go to your, do you have your Desmos Scientific open?
Yeah.
Okay, I want you to do, in your Desmos Scientific, I want you to type in the cosine of 7 pi over 4. And it's going to give you a decimal.
I think 0.99 or 0.995.
You must have your mode in degrees instead of radians. Could you?
0.707.
So do you see 0.707 here on this chart I made for you? Do you see that right there?
Yeah.
That means it goes along with this on the left. Okay, so like we already know that that's the answer, but what I'm trying to show you is that if you enter it into the calculator and you know this chart, you can shortcut your work. So like, what is the next? Could you verbally tell me the next problem that you've got?
SEC 135 degrees.
Okay, so enter that into your Desmos Scientific, SEC, which is secant, 135 degrees. And make sure it's in degrees this time.
Wait. Which one am I putting in again?
What was the problem?
SEC 135 degrees.
Okay, so your Desmos does not know how to do secant. It knows that you know though, because you're gonna remember this or study this. It's the reciprocal of cosine. So this is what you want to enter on the right: 1 over cosine of 135 degrees.
I have negative 0.707.
So negative 0.707. So notice it's this one again here. So that means it's negative square root of 2 over 2. So what I'm trying to get you to do is use the calculator, figure out which one it is in this table, and then map it to the correct rational or irrational form. But make sure you put the negative in.
I put in for my answer rad 2 over 2, right?
But you said it was negative, wasn't it?
Yeah.
So that means it has to have a negative out here.
Right.
And
I did that and it was wrong.
Is this true? Is this really what it is? SCC 135?
Yeah,
And
except it doesn't have parentheses.
Did you do 1 over cosine 135? See, I get 1.414 when I do this, or negative 1.414.
Yeah, there we go.
Okay, so that's not this one. It's the one on the right here. Right. So when you get this, you have to use, and it's plus or minus. So you use negative square root of 2. The alternative is to do it the other way, where we figure out the coterminal angle, find it on the unit circle, and then simplify. This is to an attempt to try to make this faster for you.
Right. Next one is tangent to 40 degrees.
I'm sorry, give me one more time. Negative.
Tangent to 40 degrees.
Is there a negative in front?
No.
Okay. So again, what I want you to do is go to your Desmos and enter this with the degrees.
$1.73.
Yes. Now, this is one of those that I did not get on your chart. So let me go ahead and update it here shortly with that. So actually need to grab the unit circle. So that's the square root of 3.
Yeah. Next one is sine parentheses negative 150 degrees.
Okay. So this one again, just go to your Desmos, enter in.
Negative 0.5.
Right. And then we know that that might be taken, or you can rewrite it as minus 1/2.
Yes. Okay. All right. Well, that's the end of that one.
Okay. Go ahead and share your screen whenever you're ready to look at the next stuff.
Okay. Hmm.
Okay, yeah, this one, this is some new stuff here. This is graphing. I'm going to share my screen. All right, so let me share my screen. All right, so this is new. This is unrelated in some ways to what we just did. The amplitude, you find the amplitude by finding the maximum value. So like this is not a great graph, but it looks like the maximum value is at 3. Okay, and the minimum value looks like it's down here at -3. Do you see that? So the amplitude is the max minus the min divided by 2. So the max in your case is 3 minus the min -3 divided by 2. So this becomes 6/2, which is 3. So the amplitude is 3. You can think of it as top minus bottom if you prefer. Whatever you think what will be best for you to is that okay? Is that clear?
Yeah.
All right. So now to find
that's actually simple.
Yeah, it's not. But just so you know, everything in this course, you're in Algebra 2/trig, and all we're doing is trig, and the trig part is all formulas. This is like yet another formula. The period you have to either find peak to peak or valley to valley. And when I say peak, I mean, we live in Arizona, but hopefully you recognize that's a peak. we have peaks all around. So the peak here, when I look at that peak, I'm suggesting it's looks like it's 8 pi. Would you agree with that? And this one's at 0. So you do this calculation right minus left. Grab that. Right minus left. So you do this 8 pi minus 0. And that is your period.
Okay. Good.
So the period is 8 pi.
Okay, now this one is multiple choice.
Okay. Why don't you share your screen? Maybe we can talk through it. Okay. The first thing here is whether this is a periodic function or not, and the way to answer is does it repeat? And this one does. It repeats. See how it's like sort of an up and a down, or down and an up, down and an up. Do you see that it's the same pattern over and over again?
Yeah.
Okay.
Yeah.
So this one is periodic. Now the period is peak to peak. So you got to go find 2 peaks right next to each other.
So like these ones.
Yeah. So the period is not 1. No, it's not 1. What is that first? Can you go back to the graph and find the second peak? There's the second peak. What's the x value there? Go down.
3.
3. What's the x value of the peak to the left of it?
2.
That's a valley. No. Okay.
Okay.
I mean, that's the answer, but I don't think you understand why it's the answer. It's the x value is 1 of the previous peak.
It's like, yeah, no, I get it. It's like, so the peaks are the bottom.
Peaks are the top. I mean, we have a peak. We go look, and the ones at where the 2 is a valley. So you have to go from a peak to a peak. So could you put your cursor on the first peak there? Yes. The X value there is 1. If you go down, it's 1. If you go straight down, you hit 1 on the X axis. No, straight down, 1 right there. Then go to the next peak. There. And then you go straight down, the X value is 3. And so it's 3 minus 1 is 2. That's why it's 2. It's peak to peak,
okay.
right minus left. Yes.
Okay. Okay, that makes sense now. I understand.
Okay.
Mm-hmm.
This one is periodic because it repeats. It's got the two things above the it's got one. If you go to the left, keep going left to the leftmost part of the graph.
Mm-hmm.
Keep going left. Left. So that first part with the other one, the one that keeps kind of going. Okay, let me snip this in. All right, I'm going to share my screen. All right, so what I want you to be able to see, and I know this is hard, is this part in red right here. It repeats. That's the part that repeats. All of that repeats because if I copy it, and I can do that because of the technology I wrote, if I just copy it and I move it over, I get exactly what we started with. Yeah, well, it didn't copy that very well. But do you see that if I were to trace the red again, starting here, if I trace that here, I'm going to trace exactly the same thing.
Mm-hmm.
So that it repeats here. The periodic means it repeats. The same pattern repeats. In the first one, this was the repeating shape.
Right.
Okay. Now I mentioned a couple of ways to find the period. The first is peak to peak. The second is valley to valley. But the more general one is it doesn't really have it doesn't really have it's same to same, and so that's not really the right wording, but it's like, let's say you want to refer to this little place right there, you got to figure out, well, where's that little place there? It's right there. See how it's same to same? It's this little min to this little min.
Yeah.
It's always right minus left. Okay, so this right one is at pi over 2. This is pi over 2. This is minus pi over 2 minus pi minus 3 pi over 2. And that's what I mean by left. It's the X value, right? X value minus left X value. The negatives cancel. And you get pi over 2 plus 3 pi over 2, which is 4 pi over 2 or 2 pi.
Okay.
Whenever you're ready, go ahead and share the next question, and we'll take a look at that. Okay, so does this repeat? Is kind of the first question. Does this repeat?
Yes. No.
Well, it's one of them, right? Like if you go back to the previous problem,
Yeah.
you could take whatever the part that repeats is and you just slide it left or right.
Right.
If you take that triangle from 0 to 2 in this picture and you slide it to the right, is it exactly the same?
Yeah.
So yeah, like to me, I look at 0 to 2 as like a shirt, someone's shirt, and then from 2 to 4, it's the same shirt, but it's like stretched.
Right.
So like to me, they're not the same.
Okay.
There's a complete difference between them. From 4 to 6 is like an even bigger size shirt or something like that. So this one does not repeat. It's not the same. each place.
Okay.
All right, this is a good stopping point for us. Take 10 minutes, definitely don't do any math, and please connect back with that other booking link shortly, and we'll just keep going on this stuff.
All right.
See you
Got it.
soon.
I'll see you in a bit then.
Okay, bye.